Hello everyone, I am Irene May Supilar. Throughout this video, we have here the objectives. First, determine the propagation of the sound waves and its speed through the different medium such as the air, liquids, and solids. Second, determine the reflection, echoes, and sonic boom. Third, how do dolphins, bats, and submarines navigate? As we already know, sounds is a disturbance. Sounds is a form of energy that spreads from its source in all directions. The speed of the sounds is different with a different medium. Sounds travels with a different speed with a different medium such as the solid, liquids, and gases. Sounds travel in a medium due to the transfer of energy from one particles to another particles of the medium. Since the particles of the solid are very close to each other, so the transfer of energy from one particles to another particles takes place in a less time. For example, if you are going to top the table, which is a solid, and listen. And if you are going to put your ears above the table, and as you top the table, did you notice the change of sounds? If we are going to compare of which of these are much louder? Yes, an air putting above the table, which is more louder. Hence, the speed of the sounds in solids is very high. In the case of liquids, the distance between the particles is large compared to the distance of particles in solids. Thus, the transfer of energy among the liquid particles is lower than the solids. Hence, the speed of the sounds in liquids is less than the speed of the solids. However, in case of gases like air, which the particles are far away from each other, as compared in the case of solids and liquids, hence, the transfer of energy from one particle to another particles of the gases is quite slow. Just to determine the disturbance and which of the different medium travel faster when it started at the same time. Here is an example to determine which medium such as air, liquids, and solids travel faster. This first building blocks, which is close to each other, is a solid medium. The second line of a building blocks, which is slightly greater distance with each other. This will be the liquid medium. Lastly, this building blocks, which is far away to each other, it is considered as a gas medium. Therefore, the speed of the sounds in gases is less than the speed of the sounds in solids and liquids. The sound energy needs a medium for its propagation. This time, we're going to discuss about the reflection of sounds and sonic boom. In reflection, we have a law of reflection that was being incident to the surface. Just like this. Sound waves are also reflected from the surface of the solid that was also follow the law of reflection. Shall we say we have a speaker like that was the source which is an emitting sounds. As one of the sounds waves travel and reaches the surface of the point, let's just say we have a normal line at the center of the surface which is perpendicular at the point of the incident. Then this wave will be reflected. That will passes in which it will be here. As the law of reflection tells that the sound waves is reflected back to its way, that the angle of the incident I is equal to the angle of reflection R. Shall we say our source of sounds incident with the perpendicular to its surface? In this case, the reflected sounds will travel back in an opposite direction along the same line. Now, let's talk about echo. Echo is one of the example which is reflected that we could able to hear the sounds. By the way, what is an echo? Echo is the repetition of the same sound again and again. Where do we hear an echo? Well, we usually hear in an empty space bounded by at least one surface. For example, if we shout or scream in an open space standing against the wall, we will also hear the sounds again and again. It happens when the sounds travel in all possible directions. When it reaches and bounces to the wall, it will reflect it back. That reflected sound waves travel towards us, and we hear the repetition of the sound. There are other conditions in which the echoes depends on the temperature of the surrounding and the distance between you and the point of the reflection. Now let's talk about the sonic boom. Many aircraft, which is mostly military, are supersonic, that they can fly faster than the sounds, that they can produce a sonic boom. We can hear the boom before we can hear the noise of the airplane. So what makes the sonic boom? Sounds extend in the sphere that the sound source produces vibration which travel in all directions as the waves compressed by air. As the airplane traveled in the atmosphere, this phenomenon can sound like an incredibly loud explosion, depending on the airplane producing it. When an airplane travels through air, it displaces air molecules, creating waves of pressure in concentric circles around it. In other words, sound waves radiates in all directions spherically around an object. Since the waves move at the same rate consistently, they don't overlap. But when the airplane increases to a speed greater than the speed of the sounds moving through the air faster than the pressure of the waves themselves, it forces the waves to compress and slump to each other, creating a shock wave trailing behind the object. The shock wave creates a buildup of pressure, and it is that sharp, sudden change in pressure between the cone of the shock wave and the air surrounding it that creates an audible boom. This time, let's talk about how dolphins, bats, and submarines navigate. First, how does bats navigate? We have two kinds of bats, which is the megabats that can navigate merely by sight, and the microbats, which lives in the dark places, that navigates through echolocations, using their ears to see by listening and echo. For the submarines, as the submarines dives in the ocean, they control the sea and the vessels with no windows and the depth relies merely penetrates. How they navigate? They use their ears. Submarine crews rely on a sonar, the use of reflected sounds to detect objects in the water or air. A sonar device supports the sense of first waves. When the waves hit the object in the ocean floor, it will bounce back or reflect. Reflected sound waves called echoes. For the dolphins, sounds travel extremely well in the water. Dolphins communicate one another by transferring and receiving different sounds, such as squeaks, runs, and marks. But one sounds in a particular is the sounds that which dolphins using their sonar. Through the use of sonar, the dolphins to navigate with their environment, to locate food, or to avoid from predators. The dolphin sonar works through its series of clicks by moving air through the nasal sac located near to the head hole. Dolphins require echolocation to navigate, hunt, and protect themselves from predators. And for their frequency, dolphins produces low-frequency signals to communicate, but high-frequency signals when echolocating. That's all for today. Thank you for watching.